Okay, welcome back to the Dublin Academy of Maths Online. Okay, now today this is the last of this video series, and it's Leaving Cert Ordinary Level Maths Series 4 on Episode 9, Paper 1, and we're doing Question 4, 2011, Complex Numbers. Alright, now at 4a, this is Question 4, 4a says u is equal to 1 plus 2i, and I squared is equal to minus 1. Now they're just letting you know that, okay? Now you should have the papers out in front of you, but I'll just put in what I can. Plot u. So that's the first thing it says. Plot u. U is 1 plus 2i. 1. Where's the real axis? 2, 3. 1 plus 2i. I. 2i. 3i. 1. That's u. Okay? 1 plus 2i. And it says what's u plus 3? Well, what's u plus 3? That's u plus 3 is 1 plus 2i. U plus 3 is equal to 1 plus 2i plus 3. So it's going to be 4 plus 2i. Okay, you have the real parts. So it's 2i again, and it's 4. So we're here, and it's 4 plus 2i. Okay, so it's going to be 4, 2i. There it is there. Okay? 4 plus 2i. So that's u plus 3. Okay, so it's moved across 3 spaces. And the next part it says, so that's the first part over with. And the next part it says, let's go over and change it over. It says z is equal to 2 plus 3i. Find z squared in the form of find z squared, and put it in the form x plus yi, where x and y are real numbers. Okay, I mean they're real. Okay, so z squared. So z squared is equal to 2 plus 3i. Okay, all to be squared. That's equal to 2 by 2 plus 3i. You should know this. Plus 3i by 2 plus 3i. Okay, multiply them out. So 2 2s are 4 plus 6i plus 6i plus 9i squared. I squared is equal to minus 1. I squared is equal to minus 1. So minus 1 goes in there. So you got the answer is 4. Add them. 12i. Add the real parts. Plus 9 times minus 1 is minus 9. Okay, so it's 4 plus 12i minus 9, which is 4 minus 9 is minus 5 plus 12i. Just check that. Okay, minus 5 plus 12i. Moving on. Okay, so that's that part B done. Okay, so it's continuing on, and it says show that z squared is equal to 4z minus 13. Okay. Now, well, we know what z squared is. Okay. Z squared is equal to minus 5 plus 12i. Okay. Now, so z squared. Show that z. So we've got two choices here. Okay. We can either put our original value, because z was our original value, which is z is equal to 2 plus 3i. Sorry, z is equal to 2 plus 3i. Now, what we could do is we could put our options in, we could put them in. We could put this in and see if it works out, or we could just get the conjugate of that. The conjugate of z is equal to 2 minus 3i. Okay, now we'll just use the formula z squared minus z times the sum of the roots plus the product of the roots. Okay, the product of the roots is equal to 0. So we've got the roots here, conjugate and z. So we put z squared minus z times the sum of the roots, which is 2 plus 3i, plus 2 minus 3i, plus the product of the roots, which we found out to be, okay, so we'll just put them in, 2 plus 3i by 2 minus 3i. Okay, now we've already found out parts of this, and we would have it up here because z squared was equal to minus 5. Z squared is equal to minus 5 plus 12i. Okay, so just remember that. So we put them in, and we see we've already multiplied, so minus 12. So this is minus. Well, anyway, we just go ahead and do z squared minus z times 2 plus 2 is 4. The 3 and they cancel out. Okay, so that's plus 4. And then we multiply out these two. Okay, so that's be 2 times 2 minus 3i by plus 3i by 2 minus 3i. Okay, now we've done something similar like this before. Okay, see the way they're very similar because there's not many roots they can get. Okay, so this all works out as to be well, let's work it out. So 2 2's are 4 minus 6i plus 6i minus 9i squared. We found that to be minus 1. They cancel. You got minus 9 by minus 1. So that's equal to plus 13. You see that? So that's 4 minus 9 by minus 1 is 4 plus 9 is equal to 13. So that's the 13 part there. Okay? So we really add it up and we put it in plus 13 is equal to 0. So it becomes z squared minus 4 times z plus 13 is equal to 0. Okay, let's have a look at it here. So we put it up here. And you can see that, okay, so the answer is up here, z squared minus 4 times z plus 13. And you can see that when you manipulate the top formula there, okay, I hope you're happy with that. You manipulate the top formula here, if you brought the 4z across, it becomes minus 4z, and if you come across bring across the minus 13, it becomes the plus 13. Okay? Now, so that was your choice to do there. Okay, so or you could just put in your values for z and make sure. Okay, so there's another way you can do it. Okay, so z so you've proved that the roots are equal anyway. Well, anyway, let's have a look at this way. Minus 13. Now I can put in a root there. I can put in 2 plus 3 I all to be squared is equal to 4 times z, 2 plus 3i minus 13, and then work them out and see if that is equal to that side, or bring them over and make sure to see if they are all equal to 0. But it's in essence it's the same equation, okay, but it's one of the roots, using one of the roots z to see if one is equal to the other. And we've done that before in equation ones when we found out x is equal to 1 of, say, x squared minus 2x plus 1 is equal to 0. Which is, okay, so we put in 1 squared minus 2 times 1 plus 1 is equal to 0. Yeah, 1 plus 1 minus 2 is equal to 0. So that's 2 minus 2 is equal to 0. So it's a root. So we could put 1 in for it. Okay? So that's in essence how you can do the other option of getting the answer to that. But anyway, there is yes, and you've proved yes by you showing z squared is equal to 4z minus 13. Z squared, this implies that z squared is minus 4z plus 13 is equal to 0. This implies that they're both equal. Okay? Equal functions. Or that they have equal roots, or they have the same roots. Or same roots. Doesn't matter. Once you put it down and you disclose that, yes, they are equal, or you can look above and you can see that the equation is equal. Now the next part is, let's go to the next part. It says, show that, okay, we'll just take this out. Show that, and this is part B, part 3 of the question. Show that the conjugate z squared plus 13 minus 13 sorry, this is the same equation, is equal to 4 times z the conjugate. Now it's the same principle again. Okay, you put in your conjugates. You know that z was equal to 2 plus 3i. So the conjugate of z is equal to 2 minus 3i. Okay. Now what I can do is, I have my options again, but I can put in 2 minus 3i for z again. So it'll be 2 I'm going everywhere I see z I'm putting in 2 minus 3i. So it's going to be 2 minus 3i all to be squared plus 13 is it equal to 4 times the conjugate, which is 2 minus 3i. Okay, and you would work that out. And you would prove that, yes, they are equal, okay? And they would be, because it is the root of it, okay? So one side would equal to the other. It's exactly the same equation, but with different roots. Next part. Okay, so that's part 3. Part C, now we're on part C, the hard part. 1. 4 plus 2i all over. Okay, part 1. 4 plus 2i all over 3 minus I, and put it in the form of x plus yi. Okay, so put in that form. Okay, so you put in that form. Now we were told before that if we have a fraction, we can multiply above and below line by the conjugate of the bottom line. Okay, and we do this in thirds also. 3 plus I by 3 plus I. Okay, and we multiply them out. Okay, so it's a long equation, so it goes again 4 times 3 plus I plus 2I by 3 plus I. Okay, so it's alright there. 2I by 3 plus I. Okay, so then we have the bottom line 3 by 3 plus I, and you'll find that they will cancel. 3 plus I, and you multiply them out at the top again. So you got 4 3s are 12, you should be doing this, plus 4i plus 6i plus 2i squared. I squared is equal to minus 1. I is equal to the root minus 1. Okay, so we're substituting I squared, which is minus 1 in for here, so this is minus 2. Okay, there's something wrong here, minus 3. Okay, we're doing the top. All over, multiply at the bottom, 3 3s are 9 plus 3i minus 3i minus I squared. Okay, so minus 1, that's plus 1. They cancel. Okay, that's plus. You see that there, going to be minus 1, which is plus 1. So that becomes all over 10. Okay, going back up 12 plus 4i plus 2i squared, that's minus 1, so that's minus 2. I hope you can follow this. Alright, so that becomes 10 plus 10i all over 10. Okay, so we go back up to the top. So 10 plus 10i, we change the amount, so that's the same as 10 over 10 plus 10i over 10. Let me just check that answer. Yes, okay. Now we divide on top and bottom by 10, so that becomes 1 plus 10 into 10 goes I times. Okay, so that's the answer. X plus IY, so you say that is the answer, equals. Okay, so you're going down and you say equal answer. And the next part it says, okay, so that's what it is, 1. So we're always writing these out, okay, that's what it's represented as. Okay, so the next part it says, which is usually the longest part. Okay, so you have to stay with it and keep your concentration levels high. Right, so C2 part it says, find the real values k and t. Find k and t now on this equation. So we've got 4 plus 2i all over 3 minus I, and we have to get the modulus of that times k plus 5i is equal to 1 over root 2 times 7 plus t minus 1 times I. Okay, now I'm looking at this equation. I've seen this before, we've had this before. This is from the part 1. Okay, so we know that that is equal to 1 plus I. Now I have to get the length of 1 plus I, and that's the same as square root of 1 squared plus 1 squared, which is the square root of 2. Do you see what I've done there? Okay, so I've been given this before, the previous part 1, and I found that that was equal to 1 plus I. I then get the modulus of it, which is this, I have to do the a squared plus b squared parts, and there it is, 1 plus 1 squared is the square root of 2. Now I can change this over again, and this becomes root 2 times all of this. Okay, now I have a root sign here, and I'm going to think to myself, well, if I can bring this across, I'll multiply across. Okay, I'm using the same thing, same methods as of algebra. What I bring across, I change its function. Bring across a minus becomes a plus. Bring across a division, it becomes multiplication. So that becomes root 2 times root 2 times k plus 5i is equal to, I'm taking out this bracket, plus ti minus I. I multiplied by I here inside the brackets, even though it's on the right hand side, but they're just trying to trick you up. This is all about logic. You will have learned this before through doing questions. Root 2 by root 2 is, okay, it's the same as root 4. It's not the same as, but if you just do it like this, you just cancel and you're left for 4. It's the same as root 2. Root 4 by is 2. 2 by 2 is 4. So we just cancel. So it becomes 2. Okay, so we've got 2 times k plus 5i is equal to 7 plus ti minus I. Multiply it out, 2k plus 10i is equal to 7 plus ti minus I. Okay, just checking that. Right, 7 plus ti minus I, good. 2k plus 10i. 2k plus 10i. Right, now, so now I have to separate into real parts and imaginary parts. Real, that's imaginary, 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 and imaginary. Now I've only got 2 terms in the real part, so I'm going to just go 2k is equal to 7. K is equal to 7 over 2, which is 3.5. Okay? Now this sum seems okay. I'm taking out my imaginary numbers, so I've got 10i, and then I'm going to drop the I, ti minus I. Okay? So I take out the I, so it'd be 10 is equal to t. What do I do here? I just don't get rid of the minus. It's minus 1 times I, so it's minus 1. Okay, so bring across the 1. T is equal to 10 plus 1. Okay, just checking that, and it is. It's t is equal to 11. Okay, so now you've found k and you've found t, and they are the real numbers. Okay, so you say the answer, there's the answer, and you'd highlight it. Okay, so that was question 4, 2011. Now remember, you're going to catch me on, no questions here, do the next paper. Anyway, you're going to catch me on dublinacademy@gmail.com. Okay, now Michael Dalton, I'm listed as Michael Dalton, but I want to change that to Dublin Academy. It'll either be Dublin Academy. Okay, now you can check it on YouTube on those two. Okay, so my email address is dublinacademy@gmail.com. That's my email address. And my web address is dublinacademyonline.com. Okay, www.dublinacademyonline.com. Right, now remember that, or I'll just refresh you, from here on in now it's this is the last video for this series, but it's all free, you know. It's not free. If you pay into the series, it's €20 per series, and there'll be another extra 4 or 5 videos, but the main thing here is the support. Okay, you will say to me, you could ask me a question on that series, say, Michael, what is the answer to episode 6, series 4, series 4, question number 13 or whatever, 14, whatever, it will be listed, and I will be able to do it on my tablet. Okay, and send it down to you by email, right? But when you pay into the series, I give you the whole set together, okay? Or I deal them out to you, and you give me back the answers, and I can grade you, or I can let your parents know how much or how well you're doing. Okay, so don't forget now. Remember that maths is not a novel. You can't read maths. Okay, you can't read maths. It's not a novel. You must sit down and do questions, like us all. Good luck. Thank you.